rules for cyclic alkanes, and we are also going to name them. So also, Alex makes you draw them. There's a few test questions that makes you draw them. Those are hard to practice unless you do it in Alex, so I practice that. Both with these cyclic ones and with just the linear alkanes. Okay, so we're going to use the same thing. So if we have substituents on our ring, we're going to use a prefix. If we're also going to count the number of carbons in our ring and name it based on our prefixes. So if it's 6 carbons in a ring, that's going to be hexane. But if it's in a ring, that's going to be cyclohexane. Okay, so just before our parent, we're going to add the cyclo. That means it's a ring of carbons, or a ring of whatever, but we're talking about carbon. And then the last part is we're using ane as our suffix because we just have carbon, single carbon bonds. So if we're looking at this, we count the number of corners this has. That's how many carbons. So if I start up here, 1, 2, 3, 4, 5, 6. So that's going to be hexane, and it's a circle, so it's going to be cyclohexane. Okay. If you end up with octane, then you're going to use both of the O's. Cyclooctane. I don't know if that will show up, but if it does, keep both of the O's. Okay, then when we are numbering, if it only has one substituent, then we don't need to number it because it's going to be at number 1. Okay, we don't even care that it's number 1 because there's nothing else that's going to be at our first position. So this one would be methyl, and then we have a cyclohexane. We have 6 carbons. It's in a ring, so methyl cyclohexane. This one has 1, 2, 3, 4 carbons attached to this parent ring. So our parent ring has 1, 2, 3, 4, 5. So 5 is pentane. So this is butyl cyclopentane. And we only have one substituent group, so we don't need a number to tell you where it is. Yes. Good. So basically the same rules as yesterday, just we're adding cyclo, and if there's only one substituent, we don't use a number. You didn't? Okay. All right. So if it does have 2 or more substituents, like that first page we saw, then you have to number starting with number 1 at one of the substituents, and you're going to choose by trying to make the substituent that comes alphabetically first. That one gets a lower number. So if I have ethyl group and I have a methyl group, I'm going to put ethyl at 1, and then wherever methyl shows up. Also on the ring, I can go 2 ways. I could go this way or I could go this way. I want to make sure that I'm going to go so the second substituent also has a smaller number. So it might end up at 2, or it could end up at 6. I want to make sure it ends up at the smaller number, the second substituent. So we're just trying to lower the numbers of the substituents and make sure, if we can, we're going to try to put them alphabetically lower.
So if there's only one substituent, but like say there's 2 methyls, we don't have to put do we have to number where the methyls are, or do we just put that
If there's two, then you have to number where they are, because they could be here or they could be here.
Okay.
And you want to make sure the second methyl has the smallest number. So we'll look at an example. So, this is like what you're talking about. If we have two methyls, then we're going to start with one of them, and we're going to count, so the next one is smallest. So we go 1, 2, 3. So we have 1, 3, dimethyl, cyclo, and then hexane. If we went the other way, if we went 1, 2, 3, 4, this methyl would end up at 5. So that would be wrong. We want to make sure the second group has a smaller number. Okay, and then if we have two different substituents, we have an ethyl group and we have a methyl group. We're going to pick the ethyl group as our first group at the number 1 spot, because ethyl comes first in the alphabet, and then we're going to go to methyl. And again, we want to number so the second substituent is at a smaller number, because there's two ways to go. We could go 1, 2, 3, 4, 5. That's too big. 1, 2, 3. That's correct. So then we have, this is kind of like last time, we have 1 ethyl. So we do have to specify if there's more than 1. We have to specify numbers where it is. 1 ethyl, 3 methyl, and it's a cyclohexane.
So 1 always has to be at the top, right?
So it's probably not going to look this nice when you go into Alex. Alex might have it tipped. So you just have to find, it's still the same molecule even if you.
Right. Is there a spot where we have to start with 1 though?
Yes. You have to start with 1. They picked 1 for the ethyl group.
So do we usually just
You
start
put
with
it
alphabetical?
Alphabetical, yep. Or it doesn't matter here. If you pick this one, you do 1, 2, 3. And that's the same. And if you take this and you flip it over, it's the same. So there's some symmetry here that is going to help us. Hey, questions before we move to the next one? Okay, so here, let's do this example. I'll do it up here, and then I think there's one that you guys can practice. I'm not sure. So the ring in the middle is cyclohexane. I can just see that because it's the hexagon, or I can count them. 1, 2, 3, 4, 5, 6. So this would be, my parent would be cyclo. So no space there. And then I can see I have 3, 1, 2, 3 ethyl groups. So it's going to be triethyl. But I need to renumber this. This is not numbered correctly. So I'll try to make sure that fits. So there's no space between my substituents and the parent. And then let's try to change the color. Let's try green. So I can start here. Maybe let's start over here. 1, 2, 3, 4, 5, 6.
That's the last.
Oh, so let's try it a few more. There's a few more. Or we could try maybe starting here. 1, 2, 3, 4, 5. Oh, also 6. We can go to 6. So I don't like any of these. Let's try this other way. Let me show you. So if we start at this one, oh, I have hers. 2, 3, 4. So then we have 2 ethyl groups. 1, 2, 3, and then this one's 4. So that reduced our number for our substituents. So we would have 1, comma, 2, comma, 4, dash, triethyl cyclohexane.
Wait, sorry, I'm confused. So the whole trying to make it the smallest, right?
Yep.
What do you mean by that?
So my numbers are this. If I number this way, the numbers are the smallest.
Oh, I see.
So because if I go the other way, I can go 1, 2, 3, 4, but I have a 3 and a 4.
I understand.
So these numbers are the smallest. I optimized it.
You want it to be smallest total, small amount total.
Yes, kind of.
If there was a billion, right, and some, not a billion, but a lot. And even though actually this doesn't make sense, but I understand that.
Okay. I'm not sure. That would be interesting. That would be like a math proof if you could see if adding them is always true. If that would be true. I'm not sure if that's true.
Well, I would feel like it, because the other way, we show a 3 and a 4.
So then that's
So
the
3
two
plus
figures.
4 is 7.
Okay.
And then you have another is 8, but this is only 7.
Yep. So that might be a good check. I don't know. I haven't thought through that all the way, but you could check it and see if that's true. That would be a good rule. If it's true. Okay. I don't remember if I put an example. Great. Do you guys want to do this one? Or do you want me to do this one?
Is there more outwards?
No, just Alex. Okay. Okay. Try this one and then we'll do it together. So see if you can name that.
Is that chloro, or is it?
This one's chloro. From the first slides, this is chloro.
The
Yes. It's also on the chapter 12 review or handout. If you have a CL, it's chloro.
Yeah, I'm not seeing that.
All right, are we ready? Do we need a minute? Okay, let's try it. So what would our parent ring be? Good. See my this one. Oops. Okay, so cyclic alkanes. I feel much better once I get my hair down. Okay, now what? What's next? What are we gonna do? We have to number this. How are we gonna number it? Okay, and which one's gonna be first?
I would say chloro because it's first alphabet.
Good. Chloro will be first because it's first alphabetically. So what? Then what?
Down.
Okay, so 1, 2, 3, 4, 5. Good, so we're reducing that next substituent. And I think you're adding little holes here.
I think it would, like, mathematically, I feel like it has to, because, like, if you have to do all of the, like, ways though, and.
And then, okay. Yeah, I think
That's
that.
what I did.
I think that's a good thing to remember to do. So make sure that your numbers are the smallest when you add them.
Mhm.
Okay, so we're gonna say this is 1 chloro. And we need a dash between a number and a letter. If they're different, we're gonna put a dash. Then what?
Dash,
Okay,
2, comma, 5, dash, triethyl, cyclic.
so what is this one called again?
Oh, I don't know.
Good, this is methyl, so there's just 1 carbon, so methyl. And this is, there's 2, so it's gonna be di. Oh, cyclohexane. Okay, how do you guys feel about that? Okay, good. So this is something that I would practice in Alex, make sure you're comfortable with that. I would probably do more than the homework to make sure that you're good. Okay, good. Yes, they will ask you to draw them, yes. Good. Okay, so we have about 40 minutes left, so I would probably work on the Alex homework. I would work on the lab 5 if you haven't done that and submitted that. I would work on the pre-lab for lab 34 so that you're ready when we come next time. And if you're all caught up, you could also work on that signature assignment.